Hello, let's solve another Leetcode question, and the question for today is valid parentheses. It goes like this. Given a string S containing the characters different brackets, determine if the input string is valid. There are two conditions for the string to be valid. One of them is open brackets must be closed by the same type of brackets, and open brackets must be closed in the correct order. Yep. So the question is basically saying that for a given string, the brackets need to be ordered in a way that they're valid with those two conditions. So let's look at this example. We see we have three types of brackets, and if a certain bracket is opened, it needs to be closed by the same one. So if you look at this, we have 1, 2, 3, 1, 2, 3. So we have 6 brackets and 3 opening and 3 closed. These two form a pair, which means they're closed and open properly. These two form another pair, and these two form another pair. So overall, the string is valid. So let's see how we can check if the string is valid and then return a suitable result, which can either be true or false. The first thought would be to iterate over the string and keep track of all the opening brackets. And as soon as we come across a closed bracket, we need to make sure that there's a corresponding open one which matches. So if you think about possible data structures to achieve this, a stack seems ideal because it works in a last in, first out manner. So if you think about a stack in which you have multiple elements, you keep putting items into the stack. Let's say you had 1, 2, 3, 4, and the way you remove items from the stack is from the top. So in this way, it works quite well for our brackets here. So you can keep populating brackets into the stack, and then you can change them as you iterate over the string. So let's see how it would work for this particular example. We want to iterate over the string, and for each bracket, based on whether it's open or closed, do a certain check. So for open, we have 3 types. And the corresponding closed brackets. So we start from the first index. We see that it's an open bracket, so we add it to the stack. The second one is open again, and we add it to the stack. Third one also we add. The fourth one, we see that it's a closed bracket. So we want to pop from the top of the stack and check if it matches with the corresponding open one. So we pop this out and we get this, and you see that they match. So we're good to proceed to the next iteration. And at this point, we can remove, because we popped it, it means we removed that element from the stack. Now the next one is a closed again. So we pop another one. We see that they match, so we're good to proceed. Same thing with the last one. We see that it's closed, so we pop from the stack and they match. So now that we've iterated over the entire string, what we need to also confirm is that there are no open brackets left which don't have a corresponding closed one. So we see that the length of the stack is 0. So that means we have iterated over everything and the string is valid, and we can return it true. At any part of this process, if we don't find a matching pair, or if after the entire stack has been iterated, you have some elements still which don't have corresponding closed brackets, it means that it's false. So I think this should work. Alright, let's write some pseudocode to see how this can work. We first want a mapping between the open and closed brackets. So let's just initialize a variable called mapping, which it will basically have the values that we have here, with the keys being the open and the values being the closed brackets. Initialize an empty stack. Now we want to iterate over the string. So we just do for character in string. There's mainly 2 conditions here. If character in mapping it means that it's an open bracket. So you push to stack. If we have a closed bracket and the stack is empty, we can just return false. So else if stack is empty, return false. And the final case would be where we want to check if it matches. So you just pop from stack, check if the pair matches, then return true or false accordingly. And after we iterate over the entire string, we need to make sure that the length of the stack is empty so that there's no open brackets which haven't been closed. So we can just check if the stack is empty. I think that's about it. It should work as expected. Let's quickly talk about the space and time complexity. We're iterating over the entire string once, so which means the time complexity would be big O of n being the length of the input string. And space again, because we are storing or adding things to the stack, if it's all open brackets, for example, it can be equal to the length of the input. So that would be big O of n as well. Let's code the solution on Leetcode now. We first initialize mapping, which will be a dictionary. It'll have all the opening brackets and the corresponding closed. Then we initialize our stack, which will be empty. We can then iterate over the string, for which we do for ch in s. We want to check if ch is in mapping. And this means that it's an open bracket because all our keys for the dictionary are opening brackets. If not, it means that it's a closing bracket. And if the length of the stack is 0, we can just return false. And in the third case, we want to pop from the stack and compare. If it doesn't match to the corresponding closed bracket, then we just return false. See in the code that as we go through each step or each iteration, we are making sure that we're validating the matching pairs, and if not, we just return false right away because we don't need to compute the rest. After we've iterated everything, we should have validated that every opening bracket has a corresponding closed one, the only edge case being if there were a few open ones that were not closed. So we just check and return false based on the length of the stack. You can just do return length of stack. So this will return true only if the length is 0. Let's try running this. Looks like we've got a syntax error. Oh yeah, this should just be elif. All right. Okay, that seems like it's working. Let's submit this code to see if it runs through all possible inputs. That works, and we've got a space and time complexity of big O of n, which is good for this solution. Thank you.